Any for it, Nick?
Thunder with the roar of aircraft. A secret invention quietly emerged, one that would change the fate of battles, and perhaps even the outcome of the war itself. This was the story of the radar proximity fuse, a device so small that it could be hidden inside a single artillery shell, and yet so powerful that it turned the tide of combat in favor of the Allies. Historians have often called it the second most important secret weapon of the war, right after the atomic bomb, and for good reason. To understand its importance, we must first go back to the dark days of the early 1940s. At that time, anti-aircraft defenses faced a nearly impossible task. Imagine the sky filled with enemy bombers, swarming towards cities, factories, and soldiers on the front lines. Anti-aircraft gunners would fire thousands of shells into the sky, yet most would miss their mark. The problem was not a lack of bravery or firepower, but rather the limitations of the technology of the day. Traditional fuses came in only two types: contact and timed. A contact fuse exploded only if it struck the aircraft directly, something nearly impossible when firing at high-speed planes moving thousands of feet in the air. Timed fuses, on the other hand, had to be set before firing, with the hope that the shell would explode at the right moment in the sky. But with the unpredictable speed, altitude, and angle of enemy aircraft, even the most skilled calculations often failed. Bombers would fly through storms of shrapnel and survive. The Allies needed a miracle, and soon they would get one. In 1940, as the war escalated, scientists in Britain and the United States began searching for a better solution. The idea was bold and almost unbelievable. What if a shell could sense when it was near a target, and then detonate automatically at the perfect moment? The answer came from radar technology. By placing a miniature radio transmitter and receiver inside the fuse of a shell, the weapon could detect when it was approaching an aircraft. As the radio waves bounced back stronger and stronger, the fuse would trigger the explosion at just the right distance. It was an ingenious combination of physics, engineering, and wartime urgency. The project was so secret that only a handful of top scientists and military leaders even knew it existed. Development was not easy. Early prototypes often failed. The tiny electronic components had to survive the massive shock of being fired from a cannon at supersonic speed. Engineers worked tirelessly, redesigning circuits, hardening vacuum tubes, and testing again and again. Eventually, after countless failures, they succeeded. By 1942, the first working proximity fuses were ready. When they were tested, the results astonished everyone present. Instead of shells exploding randomly in the sky, they now burst directly near their targets, showering enemy planes with deadly shrapnel. The difference was extraordinary. Suddenly, anti-aircraft guns were far more lethal than ever before. The military knew they had something revolutionary on their hands. But they also knew that if the Axis powers discovered this technology, they could copy it and use it against the Allies. For this reason, the proximity fuse was one of the most closely guarded secrets of the war. Soldiers were forbidden to talk about it, and even many officers had no idea how it worked. At first, its use was limited to naval warfare, where the risk of losing a shell to the enemy was lower. On the high seas, the proximity fuse proved devastating. Japanese aircraft, especially the feared kamikaze pilots, suddenly found themselves vulnerable. Instead of dodging bursts of flak, they were now being torn apart in midair by shells that seemed to explode with uncanny precision. As the war raged on, the proximity fuse began to spread across battlefields. In Europe, it became a powerful tool against German V-1 rockets, which terrorized London with their buzzing engines and deadly warheads. Anti-aircraft units equipped with proximity fuse shells began shooting down the rockets with far greater success than ever before. For the civilians of London, who had endured so much suffering, this was a turning point. The skies became safer and morale began to rise. On the front lines, the proximity fuse was equally effective. In December 1944, during the Battle of the Bulge, American forces faced a massive German offensive in the freezing forests of Belgium. The enemy poured in with tanks, infantry, and artillery, hoping to break through Allied lines. But now the Americans had a new weapon. Their artillery, equipped with proximity fuses, unleashed devastating fire. Instead of shells burying themselves harmlessly in the snow or exploding too late, They now burst above the German soldiers, sending showers of deadly steel down upon them. The effect was immediate and catastrophic for the attackers. Veterans of the battle would later recall that the proximity fuse saved countless lives and may have been a key factor in halting the German advance. The weapon was so effective that General George S. Patton himself praised it, calling it one of the greatest technological innovations of the war. General Eisenhower went even further, stating that the proximity fuse was second only to the atomic bomb in importance. Coming from a supreme Allied commander, this was no small statement. It underscored just how vital the invention had been in turning the tide of war. Yet, despite its importance, the proximity fuse remained hidden from the public for much of the war. Its secret was too valuable to risk. Even soldiers who used the shells often did not understand how they worked, only that they were more effective than anything before. Only after the war ended did the full story begin to emerge. Scientists and engineers who had labored in secrecy were finally recognized for their contributions. Their invention had saved cities, protected armies, and shortened the war. The impact of the proximity fuse did not end with 1945. Its principles went on to shape the development of modern weaponry. From guided missiles to advanced air defense systems, the idea of sensors triggering explosions at the perfect moment became a cornerstone of military technology. Today, when we see precision weapons striking targets with deadly accuracy, we are witnessing the legacy of the radar proximity fuse. Looking back, it is almost astonishing to realize that such a small device had such a massive effect. It was not a bomb capable of destroying entire cities in a single flash, nor a giant tank that rumbled across battlefields. It was a tiny fuse, often overlooked, but quietly deadly. A piece of engineering brilliance hidden inside the steel of artillery shells, waiting to strike at just the right time. The story of the proximity fuse is more than just a tale of technology. It is a reminder of how human ingenuity can rise in the darkest of times. In a world at war, when the very survival of nations hung in the balance, scientists and soldiers worked together to create something that changed the course of history. They built a weapon that defended freedom, protected lives, and brought the Allies one step closer to victory. As we remember the great battles and the sacrifices of World War II, we should also remember the secrets that lay behind them. The radar proximity fuse, hidden from the world for so long, was one of those secrets. Its story deserves to be told, not only as a chapter of military history, but as a testament to the power of Innovat,